So what do we mean by enhancing or adjusting the contrast of an image, of a digital image or an aerial photograph? Well, what we mean is that while we're recording something, an image on the ground, the brightness values might not vary all the way from 0 to 255 or from black to white. They might just be shades of gray in the middle, so that even though the range that the sensor is sensitive to varies from 0 to 255, in this case, maybe they only record 0 to 63 or some subset of that total brightness. So in other words, we have part of the some of the shades of gray that we wouldn't use in the imagery if we don't do this adjustment. So basically what we do with the adjustment is we take these values here and we stretch them out so that they fit the entire range for display on our screen. This is not how they were recorded, but how they're being displayed on the screen. So this would be a contrast adjustment. So one type of contrast adjustment is called a linear stretch. And in this example here, the minimum brightness of the image and the maximum brightness of the image are not as, it can be extended to reach the minimum display brightness and the maximum display brightness. So we take this original histogram and we stretch it out, or linearly stretch it out, so that everything gets adjusted along that histogram. So it just starts closer to white at one end and black at the other end, and then we get more of a contrast in our image. That would be a linear stretch. Once again, in this example here, these would be all the different brightness values, and we can see that they really just vary between 51 and 153 here. After we do this linear stretch, then they would vary for display purposes between 0 and 255. So we'd be going all the way from black to white. Another type of thing besides a linear stretch is something called a histogram equalization. In this example here, we see the histogram. These would be all the brightness values that we've measured with our remote sensing instrument. And once again, these do not vary from 0 to 255, so we stretch them out so that they do vary from 0 to 255. In order to do this and keep the same heights for some of these different bars, we actually just put some in between that don't have any values or won't have any brightness values associated with them. So this would be a histogram equalization, where everything is stretched out, but in a different manner than that linear stretch that we were using before. And in this example here, once again, this one started by varying from 51 to 153. It's once again stretched out, but everything is not stretched out in an equal linear sense here. Some things are taking up more room, such as this big high here, and other things are taking up about the same room, such as this, this lower high over here. So by using these contrast adjustments, here's the type of effect we get. This is a histogram equalization here, and we can see we start out with this darker image on the left here. It's darker, but it's also lower contrast. So we can look at some areas, for example, right in here, where I can see a darker area here and a lighter area here, but I can see that much better, this darker area and this lighter area here, after the contrast adjustment. And it's also quite clear that we're getting up into that white area in a lot of these, because in this, the white area here was not used very extensively. There were some white areas, but there's a lot more of this image that we can use this contrast adjustment to bring out those areas, to increase the contrast between the different shades of gray by using the full 0 to 255 intervals of our final display. And of course, we can also do this with color imagery. That was just showing one band. If we combine 3 different bands, we might get a contrast adjustment that looks like this. Or once again, we're just seeing a lot more contrast between darks and lights in the image on the right than we are the one on the left.